academic students, I am Pandey. I welcome you all in chemistry practical class. Aim for today's experiment is to determine the strength and molarity of the given solution of hydrochloric acid, formula is HCl. Given is M by 20 Na2CO3 sodium carbonate solution, which means we have to find the strength and molarity of a given solution of hydrochloric acid with the help of M by 20 sodium carbonate solution. See, dilute HCl is taken in the burette. Dilute HCl solution is taken in this burette. M by 20 Na2CO3 solution is taken in titration flask. We take Na2CO3 solution in this titration flask. And for the preparation of M by 20 sodium carbonate solution, we need 1.325 gram of Na2CO3. And when we dissolve this much gram of Na2CO3, which is 1.325 gram, into 50 ml of distilled water, we get a standard solution of M by 20 sodium carbonate solution. The process I discussed in the previous video, the process remains the same. What is chemical equation here? Sodium carbonate reacts with 2 moles of HCl and gives 2 moles of sodium chloride plus 1 mole of water plus 1 mole of carbon dioxide. What is indicator here? Indicator is methyl orange. Indicator is methyl orange. Why we use a methyl orange? Because in this we take strong acid versus weak base titration. End point is yellow to pinkish red. First, the color is yellow because the color of methyl orange in basic solution is yellow and in acidic solution it is pinkish red. In observation, we take 3 readings in which we write first initial reading of the burette, then final reading, and then take the difference, which gives us the amount of the volume of HCl used in the titration, which is used to neutralize the solution to obtain the end point, which is yellow to pinkish. Now move to the calculation point. For calculation, we write M1V1 is equal to M2V2, which is here M molarity of HCl into volume of HCl divided by molarity of sodium carbonate, volume of sodium carbonate, which is equal to stoichiometric coefficient of HCl and stoichiometric coefficient of Na2CO3 in the balanced chemical equation. Okay? Now move to procedure part. First we have to prepare M by 20 standard sodium carbonate solution. This is M by 20 standard sodium carbonate solution in which 1.325 gram of sodium carbonate is dissolved in exactly 250 ml of distilled water, and this level touches the lower meniscus, touches the east glass bar. So this is the standard solution of standard M by 20 solution of sodium carbonate. This burette is first washed with distilled water and then with sodium carbonate solution. This is already washed and dried. So we have to add the standard sodium carbonate solution in the titration flask and the HCl solution in burette. This is HCl solution. Now maintain the level, remove this conical flask and maintain the level of meniscus to the initial position. Now it is visible that the lower meniscus touches just the starting point, just the starting point. Now we have to pipette out 20 ml of sodium carbonate solution and transfer it into titration flask. See, this is 20 ml of standard sodium carbonate solution. Transfer this to this titration flask. Then put 1 to 2 drops of methyl orange, which is here indicator. See, the color is yellowish, which is the color of methyl orange in basic medium. Now we have to titrate this against the standard. We have to titrate the standard sodium carbonate solution against the HCl solution. Never touch the last point in the titration flask, which alters the end point, because the droplets of HCl may stick to the titration flask. Add this dropwise with constant stirring. Never touch the end of the burette to this conical flask. See, the color just changes from yellow to pinkish red. The color just changes from yellow to pinkish red. This is our end point. This is our end point. See the reading. The reading is 10.5. Reading is exactly 10.5. And we have to repeat this experiment 2 times more so that the concordant volume is obtained. This is 20 ml sodium carbonate solution and this is methyl orange. 2 drops of methyl orange. See, the color is yellow. Color is light yellow. Then again titrated against sodium, hydrogen chloride, hydrochloric acid. Add HCl dropwise. With constant stirring. And never touch the end of the burette to the conical flask, because it alters the end point. It alters the end point because the droplets of HCl stick to the walls of the conical flask, titration flask. See, the change in color. First the color is yellow and now it is pinkish red. Now the color is pinkish red. This is term time. I am taking the 20 ml of sodium carbonate solution and this is methyl orange. 2 drops of methyl orange. See, the color is yellow. Color is yellow. Then titrated against hydrochloric acid. Adding HCl dropwise with constant stirring. So the color is yellow. At end point it changes from yellow to pinkish red. See. Color just changes from yellow to pinkish red. Yellow to pinkish red. And the reading is 31.7. Now move to calculation part. See, as the initial reading of the burette is 0 and for the first experiment the value is 10.5. The volume of HCl used is 10.5. The difference is 10.5 ml. For the second experiment the initial reading is 10.5 and the final reading is 21.1. The difference is 10.6. For the third experiment it is 21.1 initially and finally it is 31.7. The difference is 10.6. So this is the concordant volume. This is the concordant volume which we used in the calculation. See, the concordant volume is 10.6 ml. The concordant volume is 10.6 ml. As we know the formula, MHCl into VHCl, that is molarity of hydrochloric acid into volume of hydrochloric acid divided by molarity of sodium carbonate into volume of sodium carbonate, which is equal to stoichiometric coefficient of HCl and divided by stoichiometric coefficient of sodium carbonate in the balanced chemical equation. And see here, the stoichiometric coefficient of HCl is 2 and the stoichiometric coefficient for Na2CO3 is 1. So this is 2 by 1. This is 2 by 1. When we change this formula in order to calculate the molarity of HCl, we get 2, which is the stoichiometric coefficient, 0.05, which is molarity, which is m by 20. M by 20 is written as 0.05 into 20, which is the volume taken of Na2CO3 in titration flask, and 10.6 is the concordant volume. 10.6 is the concordant volume, and we have to find the molarity of HCl. When we solve this, we get 0.188 molar solution. Means the molarity of hydrochloric acid is 0.188. Now we have to find the strength of hydrochloric acid, and for the strength the formula is molar mass multiplied by molarity. And the molar mass of HCl solution, as we all know, is 36.5. 35.5 of Cl and 1 of HCl. When we add this, we get 36.5 into molarity. Here is 0.188, 0.188. And when we solve this, we finally get the strength of HCl solution is 6.862 gram per liter. So the result is the molarity of HCl is 0.188 molar and the strength of HCl solution is 6.862 gram per liter. Okay, thank you.